Hey students, this is lesson 5.7 and today we are going to learn how to write an equation of a trend line and of a line of best fit and to use a trend line and a line of best fit to make predictions. Go ahead and do the review and we'll check back with you.
Record now. All right, students, we're going to make a scatter plot and we're going to describe the correlation with one of those terms that you had in the review there, either positive, negative, or no correlation. To do this, the first thing we're going to have to do is make a scatter plot. So choose an appropriate scale for study time, our hours. We'll put that on our x-axis, so our hours of study. And on the y-axis, we'll put the other variable, which is the grade earned. All right, now just looking at the numbers, it looks like for study time, we need to go up to at least 7. So it would be appropriate just to use a scale of 1 there. And for grade, we need to go to, it looks like a little over 90. So we could go by, say, 10s on that, on the y-axis. So let's make this 20, 40, 60, 80, and 100. All right, I'll go ahead and plot those points, and I'll check back with you. All right, you should notice that as the hours of study go up, the grade is going up. And if I draw a line in here to just kind of model the trend, you'll notice that the line has a positive slope on it. So we're going to say that this has, the relationship is a positive correlation. All right, can you try that? All right, the next thing we're going to do is learn how to find a trend line for a scatter plot, which is which way the data is going, modeled by a line. And then we're going to find the equation of the line, then we're going to use that equation to make an estimate for the variables. So here's the situation. We have deer population and some years, and we notice that the population is increasing. What we're going to try to do is predict the increase in the population by using an equation, and then use the equation to estimate the 12th year of that study. So again, let's make a graph of this, and it looks like it would be appropriate for the years on the x-axis to go up by 1s, and it would be appropriate, well, the populations are in the thousands for the deer, so this is going to be deer population. And I'm going to skip a little bit here, so this little squiggly means that I'm skipping some, and I'm just going to start at 1,000. And then I'm going to go by 100s. So this would be 1,200, 1,400, 1,600, 1,800, and that should be good. And go ahead and plot those, and I'll check back with you. All right, so here we have a scatter plot. We can see that there's a positive correlation between the years and the population. And what we're going to try and do is model that with a line. So I'm just going to take a straight line. If you had a ruler, you could use a ruler to do this, or anything straight. And what I'm going to first try and do is sort of get the same slope as the dots with my line. And then I'm going to move the line into the dot, so I have about the same number of data points above the line as I have below the line. And then I'm going to write the equation of that line. Now, to write an equation, we're going to use this form. So we need to know the slope, and we need to know the y-intercept. We can just estimate the y-intercept off the graph there, and it looks like about maybe 1180. So we got that. Now we just need the slope. And the slope, we're going to use 2 points to get that. 2 points that are either on the line or have the same slope as the line. And I think I like these two. They're both about the same distance above the line, so they would have the same slope as the line. So that's this point here and this point here. So, and our slope is equal to 1680 minus 1375 divided by 6 minus 2, and that equals, all right, so our slope is 76.25. I'm just going to round that to 76. And now I have an equation. Now, this equation, the input is the years, and we're going to take 76 times the number of years plus 1,180, and that's an estimate of the population. We want the 12th year, so we're going to input 12 into the equation. So I'm going to do 76 times 12 plus 1,180. And Ashlyn, what is that?
Oh, I got it. It's the calculator. Yep. Okay. So plus 1,256.12.
Okay. And that's an estimate of the population. Whoop, Ashlyn did that wrong. You might want to do that yourself.
What?
What Ashlyn meant to say was 2,092. So she thought this was a decimal number and not multiplication. So the population is about 2,092. All right, you try that. Hey students, one thing I want you to notice about the way we used our equations. In this problem, we found we used our equation to find the deer population year 12. Notice that 12 is outside the data. When that happens, that's called extrapolating. And it's generally considered that it might not be as accurate because you're not within the data, you're outside the data. And when we found this panda age, notice we were finding for 7 months, which was inside the data using our equation. And when you do that, that's called an interpolation. And that's generally considered to be a little more accurate when you're using data to find an answer within your data. All right, the next thing we're going to do is learn how to use a graphing calculator to find the equation of the line of best fit. And then we're going to try and find the correlation coefficient, which your calculator can do for you also. And once we find that, then I'll kind of explain what that is. But the first thing you need to do is get your calculator and press the stat button and then press enter. And you get these tables here. At this point, you're going to put the data into the table. So I'll stop here while you do that. Okay, now that I have my data in, I want to make a graph of this. And the way I do that is I press second, y equals, and then just press enter. And I have to turn the plot on, so notice it's blinking on, just press enter there. Then you have to choose the type, which is the first type I want there. My lists are the correct lists. I'm arrowing all the way down to mark. I like to change the mark to this when I make these kind of graphs. So I just arrowed right over to that and then pressed enter. Now I need to make a graph of this, but I know my window is not going to be right. The quickest way to get the correct window is press zoom and stat, because I'm doing statistics from, and that's number 9. Press enter, and we get a graph, and there it is. And we notice there's a positive correlation here. And the next thing I want to do is to find the line of best fit for that, which is an equation. Now to get the line of best fit, I'm just going to quit out of here, which is second mode. And then I'm going to press my stat button. And notice if I arrow over one to the right, I get a calc menu, and in there, there's a thing called a linear regression. It's number 4. I'm going to press that. And it's asking me right now if these are the right lists. And they are. I want my X variable to come from L list 1 and my Y from list 2. And so we can go ahead and calculate. On some calculators, you won't get this menu. You can just hit enter to calculate. And right now, I'm getting 2 values there. The A value, notice, is the number in front of the X, which is the slope, so 4.65. And the B value is 74.2 about. So I'm going to write that down. Y equals 4.65x plus, I forget what that one was, 74.2. I'm rounding these, 74.2. Okay. And I'm going to put that into my calculator just so I can see how well that fits. I'm going to press Y equals do 4.65x plus, that was 74.2, wasn't it? Yeah, 74.2. And I'm going to graph that. And that goes right through. So that's actually the calculator averaging those points there. All right. And now we need the correlation coefficient to 3 decimal places. And then we want to predict the average heart rate after 12 minutes of jogging. Let's get that prediction right now. The quickest way is just, let's go to the table. And the heart rate is the Y value, and the number of minutes of jogging is the X value. So we're just going to scroll down to 12. And our equation shows 130 for that. So after 12 minutes of jogging, we would expect, and this is an extrapolation, so let's call it this, Y at 12 is equal to 130. We just got that from the table. And the last thing we need is a correlation coefficient. The correlation coefficient is a number that represents how accurate this line is. The closer the number is to 1, the more accurate it is. 1 would mean 100% accuracy. And we can get that from the calculator. Quit out of there and press your stat button again. And then where it says calc, if you press the first one, 2 variable stats is what we want. Press enter. And again, it's asking me if I have the right lists, and I do, so I want it to calculate. And we need to arrow down a little bit here. And right, I think it's the last one on this list. It's actually an R value. Maybe I passed it. All right, sorry about that. I forgot where the R value is, but again, we need to calculate the linear regression, which is number 4. And here's where that R value is, or the correlation coefficient. You press the variables button, and then go down to stats, or number 5. Enter, over equation. And it's number 7 there. You see it there, that R. That's the correlation coefficient. And what that's going to do is tell you how good of a line it is. So how well does it match? If it was 1, then it matches perfect. So 0.99 means it's correlating to the data really well. So we're going to write that down, 0.99. Okay, and the 3 decimal, I don't know what the next one was. 1 maybe. Okay, all right, you go ahead and try that. If you need to go back and follow the video to get the information, go ahead and do that. All right, identify whether relationships are causal. The following situations, is there likely to be a correlation? If so, does the correlation reflect a causal relationship? All right, so the height of a student and the grade earned on a quiz. Well, I don't think there's any reason why the height of the student and the grade earned on a quiz are related. So we're going to say there's no correlation on that. So we're not going to look for a causal relationship there. No correlation. Unless the directions for the quiz were written in such a high place that only a tall student could find it. The price of bananas at a grocery store and the number of pounds of banana bought. The price of bananas at a grocery store does depend on the number of pounds of bananas bought. So if there's a dependent relationship, then there's some kind of a correlation. So yes, we have a correlation between them. You tend to buy less pounds if the price is higher. Now, is there a causal relationship? In other words, does the price of bananas specifically cause you to buy more or less? And I would say yes, there is a causal relationship. All right, you go ahead and practice one of those. All right, that's it. Go ahead and do the lesson check, and we'll talk about this next time we meet in class.